Good day, sir. We are Group 1, Group 2, and we are presenting quiz number 1 for the members. Mark Calzado, Jay De Castro, Mark De La Peña, Nel Federizo, Joshua Galera, Jericho Granado, and Dennis Gusela. So for the next page, the task is a recorded video explaining how to add a non-complainer vectors treaty. Don't forget to include sample problem. Assign a leader. Only the leader will attach your work. The leader must also include in the private comments his group number. The rest of the members will only turn in without touching anything. They also need to put in private comment their group number. So for the next page, we are explaining about what is non-complainer vector.
Good morning. What is a non-coplanar vector? If two vectors intersect, they lie in the same plane, the plane defined by those two intersecting lines. The vectors are said to be coplanar, meaning sharing a plane. If two vectors don't intersect, there is no common plane, so the vectors are said to be non-coplanar. Next.
What is a non-coplanar? What is a non-coplanar force system? It describes a concurrent system consists of forces that intersect at a point. A parallel system consists of forces that intersect at infinity. The most general system is called non-concurrent, non-parallel, and as the name implies, the forces are not all concurrent and not all parallel. The resultant of a non-coplanar force system is a force R and a couple M, where R is equals to sigma F, the vector sum of all forces of the system, and M is equals to sigma M, the vector sum of the moments of all the forces of the system. The value of R is independent of the choice of the base point, but the value of M depends on the base point. For any force system, it is possible to select a unique base point so that the vector M representing the couple is parallel to R. This special combination is called a wrench or screw.
The vector equations R equals to sigma F and M equals to sigma M may be applied directly to non-coplanar system. To determine the resultant or the scalar equations in the x negative and y negative and z directions may be used. Next slide. Next slide. This is we will show you how to add a non-coplanar vectors 3D. Next slide.
Before we begin on the sample problems, let me just say that our sample problems will serve as our guide to answer how to add non-coplanar vectors in 3D. Next presenter, please.
In sample number 1, resultant of non-coplanar force system. The system of three non-coplanar and non-concurrent forces are shown in the figure. The force F sub 1 is parallel to the y-axis and F sub 2 is in the XY plane, and the F sub 3 is in the XY plane. Determine the vector resultant relative to the origin, and the resultant magnitude dimensions are in cm. The three forces and the moment of each one creates when moved the origin are expressed as, and the F sub 1 is equal to negative 500, and M sub 1 is equals to 500 times 0.25 minus 500 times 0.16k equals to 125 minus 80k. and the f sub 2 is equal to negative 300 times 16 over 20 minus 300 times 12 over 20 k equals to negative 240 minus 180k, and the m sub 2 is 180 times 0.16 minus 20 times 0.25 equals to negative 31.2. The m sub 3 is equal to 800 times 0.707 I equal minus 800 times 0.70 equals to 566 I minus 566 J, and the m sub 3 is equal to 800 times 0.707 times 0.25 k equals to 141.4 k. Excellent. Observe that we use the 3, 4, 5 triangles to find the component of f sub 2. The component, the force, and the moment are added to obtain the result related to the origin, and the R is equal to negative 240 plus 566 plus negative 500 minus 566 minus 180 is equal to 326 I minus 0.766 minus 180 kN newtons, and the M is equal to 125 I minus 32.J plus the negative 80 plus 141.4 K. It is equivalent to 93.8 I plus negative 31.2 plus 61.4 K, and the magnitude of the resultant force and couple R is equal to square root of 326 cube plus 1666 squared plus 180 squared equal to 1080 Newton, and M is square root of 93.8 squared plus 31.2 squared plus 61.4 squared is equal to 116 Nm.
So let's proceed to sample problem number 2. This will be a concurrent system problem. So the following formulas will be necessary to solve this specific problem. The resultant force and the resultant force and the direction cosine formulas. Next slide. The three non-coplanar forces displayed below pass through the origin. Determine the resultant by finding its magnitude and the angles it makes with the coordinate axis. The distances shown are in centimeters. So this is our problem. Above are the given. So in f sub 1, we have ATN. It's f sub x 0, f sub y ATN, f sub say 0. In our f sub 2, we have 140n. Its f of x is 140 cosine 26.57 degrees, equivalent to 125n. F sub y 0 and f sub say 140 sine 57 degrees, equivalent to 62.6 newtons. So in the third one, or the f sub 3, we have 150n. And in our f sub 3, we will be using the resultant formula. So we apply the resultant formula and substitute the given from the 150 Newton angle, which is 60 from the x-axis, 70 in the y-axis, and 10 here. So R is equal to square root of 60 squared plus 70 squared plus 10 squared. Then it is equivalent to 92.74 centimeters. So we will use this resultant to solve for our f of x, f sub y, and f sub c. In our f of x is equal to 150 times 60 over 92.74. 150, of course, the n. 60 is the given in the x-axis of f sub 3, and the 92.74 is the resultant. The answer is 97.0 n. And f sub y, 150 times 70 over 92.74 equals 113.3 n. Last f sub c is equal to 150 times 10 over 92.74 is equal to 16.2 n. Just a second. So the magnitude of the resultant is found to be, we'll add the same coordinates or here. R is equal to square root of 125 plus 97 parenthesis squared plus 80 plus 113.3 squared parenthesis squared rather plus 62.6 plus 16 parenthesis squared, and the magnitude of the resultant is 305 n. Next, the angles it makes with the coordinate axis are cosine theta x is equal to 222 over 305 equal to 0.728. In theta, it is equivalent to 73.3 degrees. Cosine theta y, the answer is 50.7 degrees, and cosine theta c, the answer is 75.0 degrees. To summarize, there is no couple to be accounted for since all forces pass through the origin. So that's all for our sample problems. We'll proceed to the next slide. So here's our sources, or our only source for this project. And that is our quiz one. Thank you and have a good day, sir.